Okay. Hi, everyone. In case you didn't know, we're the Smart Medicine Dispenser team. And today we're going to talk about our team, our device, and our progress. So I'm Jo Ellis. You can call me Joe. I'm the project manager and electrical engineering major. And my responsibilities on the project were the device to cloud connection and the device display menu.
My name is Chris, electrical engineering senior, and I was trying to answer support design and the notifications.
I'm Nick. I'm also an electrical engineering senior, and I was in charge of motors and notification triggers.
I'm Regenis. I'm electrical engineering senior, and I was in charge of the user website and the database.
Hello, my name is Samuel Akinolu. I'm senior engineering science major with preference in computer engineering, but a minor in electrical engineering, so mid-sense. I'm involved with mechanical design, also just the manufacturing.
We had two advisors on our team. Dr. Larry Perlstein is with the Department of Electrical and Computer Engineering here at the college, and Dr. Karen Yan primarily supervised SAM's components, and she was in the Department of Mechanical Engineering. So what is the Smart Medicine Dispenser? Its primary function is a daily pill/capsule prescription organizer with automatic dispensing. It has a 28 compartment capacity, so 1 to 4 times dispensed per day for 1 to 4 weeks. Its features include user website for data entry and cloud for data storage, device display with menu for easy prescription information access, and a 2-part notification system for user reminders. Its purpose is to alleviate the stress of remembering to take daily pill/capsule prescription medication.
So let's start us off by just talking about what is right, which is our housing for some of the parts of the project. You can see here on the presentation, the housing, the CAD drawing of the housing that has sort of everything that's going to be the end result at the end of the semester. It has the PSUs, which is our pill storage units, not to be confused with power storage. Not to be confused with the other acronym of PSU, but for us it means pill storage units. And here on the housing, you see the clear part is the acrylic material in front of you, and everything else that's a solid color would be either 3D printed or the machine shop with like aluminum sheet metal. So yeah, you have your PSUs, the display mount, which is to house our LCD. We have, and then also the motor mounts, which is how we're going to interface the motors themselves with the PSUs, and the surface will be what you're looking at in front of you, how it's positioned right there. Next slide. Some of the additional components to make this all work was to design the PSU gear shaft, which the reason for this, as opposed to just a regular cylinder that you can insert things into, is so that it can only go in one way. One of the issues that we talked about is how we're going to set a 0 position that allows the PSUs to spin around to dispense at the proper times, but also keep everything from just falling out whenever. So having one blocked off section, and that blocked off section being the part of the gear that has the bigger teeth. So we have that as a mechanism to determine how the user is going to insert the PSUs. We also have the motor shaft adapter, which is how we're going to connect the shaft of the motor itself to the PSU gear shaft. And then the last thing on your screen is the dispensing tray, which is the collection basin for when the pills fall out. So right now you can see it in the housing. It's just sitting down there. It's the green thing. But at the end of the semester, there will be other walls all around the device, the walls, the size of the device, and it's all going to end up at this funnel thing that we take out and pull out of the pills. This video is describing the PSU and the motor that we worked on last semester. It just shows the basic functionality of how this is supposed to work. The motor is turning the PSUs after it clears the blocked region, dispenses its contents. And this is just what you have in front of you.
Our Smart Medicine Dispenser will be using 4 different motors for each of their PSUs. They will each spin separately to select the correct unit for dosage that day. And the video is showing 3 of our motors currently moving to the 5th position.
So this is the printed circuit board populated with parts. So you can see we have our microprocessor and controller on that side of PCB along with the modem and the wire connections to the motors. And this is the front side of the PCB. So we have the display LCD as well as 3 buttons to navigate menu on the LCD, as well as the laser speaker and LED for the communication system. And the idea is like use the PCB, keep everything organized, make sure the connection and signals are stable. So here, the first 2 revisions of the PCB, we plan on doing at least one more, or hopefully just one more, to get rid of some parts that we're no longer using, and just kind of really finalize its cleanliness. It's definitely not cleaner because we put the design revision, so really want to be like pristine as possible.
For our notification system, we're having 2 different triggers. Our first trigger starts the notification system, and that is our motion sensor shown on the left. It senses when the pills have fallen into the tray and will start the notification system to buzz and light up. And then when the tray is removed, it will stop blocking our output interrupt on the right, which causes the notification system to cease buzzing and blinking.
So just to kind of review what Nick was saying, and what Sam was mentioning with the physical enclosure, here's where the notification system is. That's just the LCD. And the way the notification system works is through interrupt service routines. So the motion sensor will send a voltage to the microcontroller, and it will trigger the ISR to keep a pulse width modulator on for the LED and the piezo speaker. And then once a voltage is noticed from the optical interrupts, so once the doors pulled and that interrupt is like triggered, another ISR will trigger to notification. And then on this next slide, I can go down on the notification system, and I'll just let myself talk.
So for the notification system, this motion sensor here is going to detect when a pill has been dispensed, and this optical interrupt here will sense when the drawer has been pulled. So a piece of the drawer will be in between those 2 squares, and the microprocessor will sense when something has been removed from in between those squares. So once the drawer is taken, the notification system will stop. For the purpose of a demo, I'm going to use this printed circuit board. And now I'm going to plug in the device, and this motion sensor is really sensitive, so we should hear that buzzer go off right away, and you can see here the LED is blinking as well, and this beep happens sporadically, and it will keep beeping until the optical interrupt has the tray removed. So you'll notice that once I take away the PCB, the light will stop and the buzzing will stop as well.
And the main idea with like the intermittent buzzing was like if someone is in like another room, or maybe there's like a bathroom or whatever, like having the buzzer just going and going and going when they might not be able to like take a medication yet, it's probably gonna be really annoying. So that was the idea of just having the buzz like every 10 seconds or so. And then like, the LED is just always on, so that maybe they like don't hear the buzzer go off. They can at least like maybe walk past the device and see, oh, I gotta take minutes.
So along with that, we have a menu on the physical device. It's going to be displayed on that LCD that was previously shown. It is a 3-part menu. The first option, today's doses, is so that users can see what prescriptions have been or will be taken for the day according to what was recorded in the user website and is in the database. The second option, detailed info, is to see the time that they were removed from the tray versus the time recorded as having been dispensed. And the third option is to refill the device. That is so that the user can set it in refill mode, so all of the PSUs are zeroed location, so they can open it up and manually refill each compartment. Now it'll just be a demo of that menu going.
Okay, so this is the main menu. Here are the 3 menu options. Button 1 will tell you today's doses. It shows dose number 1, the time that it was supposedly dispensed, and the time that it was taken refers to when the optical interrupt sends that the tray has been removed. We press menu back. Then option 2, which is detailed info, this will tell you dose 1 refers to one specific compartment, the time that it's meant to be dispensed, and then what is actually in that compartment, and what the database shows is the remainder of that prescription. Then the third menu option is to refill the device, and that will take you through the sequence of refilling device. It asks you for a second step to verify, just so that you don't accidentally dispense everything. Do you want to refill the device? Yes. You want to refill the device, so it'll show you this display message. This during that message, the motors will have been spinning to the 0 position to allow the user to open up the device and manually refill. Then you press OK, and it takes you back to the main menu. Okay, so this is the main menu.
All right. Okay. Next is the device to cloud connection. So this is a 3-part process. First, we have the PSOC microcontroller unit has to be connected to our cellular modem, because that's how we're connecting to the internet. We did that through UART, the same that the previous group did before with the receiver and the transmitter, as well as the serial port, because we used TerraTerm in order to communicate with the modem. It allowed us to send AT commands and receive back OK, confirming that the modem is in fact connected to our microcontroller unit. The second step is to connect the modem to the cloud, which is what we're currently working on. We're going to do that through MQTT, and we're currently trying to work with free RTOS and operating systems so that we can get that integrated to work. Then the modem will act as the middleman, I guess, for the cloud information to be sent and received by the microcontroller unit. We need it to be a 2-way communication, because we want to send back confirmation that it's time to update the pill count once the user has taken the medication after it was dispensed. So we want to be able to update the cloud and also get information from the cloud.
As for the website, this is just a general overview of what it's supposed to look like. Essentially, each blog is its own web page, and that diagram just shows the relationship between each web page. For this presentation, we're going to focus on 3 specific web pages: the login page, which is our websites that have user authentication. So user will create their own account and log in and input their information. And the second important thing is the dashboard, essentially just a home screen that will show when each cell is going to be dispensing at what time. And also it will show various other information to the tabs. The third page is the medication page. It will show you a list of every medication that you input in the device, and eventually it will also show which medication being was specific. This video here, it will show the website that's currently. Essentially, you go into the website, it's a login screen, you enter your username and your password, and you press login. It verifies that you do have an account, and once it verifies that, it will take you to the dashboard. You can see here there's no dispense space, but there's one medication, and essentially you first have to go and create a device. Then you see your smart medicine dispenser using a username, and then you can name your device anything you wanted. Let's say just smart medicine dispenser. Then you press submit. It will record that link and connect your user to the device. Then you just input the medication names. Let's say you take the Tylenol 100 milligrams every so often. Use inputting information to keep it stored. After you do that, this is when you will input when do you want each cell to dispense a pill. Let's say you want to dispense on Saturday, every Sunday, so on and so on. You will input all the information and keep the log so that every Saturday it will dispense at the same time, and so on and so on. I skipped a bunch of rest stuff, or I just input random values, as you see here. And once you press submit and proceed, you're basically just done with the main part of it. You go back to the home page, and you'll see that it shows you when each cell will be dispensed, or when it will be in next dispensation. And you can also see that it also updates the medication on table. So it shows you all the accurate information. Eventually, as semester, you're gonna get to also specify which cell you want each medication to go into, so that you will know that also 1A is for terminal, so 1B is for officials, and so on and so on. As for the cloud database, this is just the general overview of what it looks like. It's just a bunch of different data tables that interact with one another. And the database is used to store all the data that we're using, all the times, all the medication, and so on and so on. It will be basically a cloud server that will be updated by the website and modem, and just keep track of everything.
So to summarize, what we have completed is the pill storage units and motor mounts design, the motor spinning to dispense the medication, general purpose use of the user website. The website and the database is linked. The PSOC and the modem is linked, and our notification system, motors, and the display are functioning through the PCB. In progress, we currently have the PSOC to the cloud connection link, synchronous function of all components from one workspace. So obviously at the end of the semester, we want all of our components to be within the housing and functioning through the stick microcontroller unit. We want the detection system to be fully mounted on our associated components, and then we want the modem functioning through the PCB and the device housing to be fully completed and assembled. Do you have any questions?
So for like this law, smart sensor, how does it know what time of day that it is? Is that like cloud? Sits in that?
Does PISA have its internet clock?
So that is something that we're currently working on because we want it to be autonomous, obviously, but there is a clock within the PSOC environment. But we're trying to decide if we want it to rely on the MCU or if we want the modem to constantly pull the time information from the database and feed it to them. But that is currently in progress. Yes.
Is the Cloud SQL database, and then it's like just Cloud SQL on Google, and just you input SQL code, and then it's connected to the modem using MQTT, and like a different RT4 software by Google.
Any other questions?